All right, so the next vulnerability we're going to look at is reflected XSS. Now previously, so in the previous video, in the previous two videos, part 10 and part 11, we've looked at directory traversal or path traversal. Now we're going to look at the reflected XSS, and we're 19% into Hacksplaining. And again, I'm going to share my experience as I go through these types of vulnerabilities. I'm actually going to share my experience from my application security testing projects or assessments. So let's look at the reflected XSS. In this video, we're going to do the exercise, and in the next video, we're going to do the prevention and quiz. Now, to be honest, I'm not a big fan of XSS. I do not look for XSS outside of the very basic generic payloads. So it's not like you're not gonna find me, or you're not gonna see me looking for XSS or craft an XSS attack vector hours at end, because in my preferences it does not have a very high spot in the priority list. So I'd rather focus on authorization and access control issues than on XSS. XSS, SQLi are really boring to me, and it's something that I do not usually look for other than the generic stuff. That being said, let's actually look into the exercise. So, when building a website, you need to be sure you do not accidentally create a channel that allows malicious JavaScript to be bounced off your server. A reflected cross-site scripting attack. So, let's see how you might be vulnerable. Previously, we saw how some XSS vulnerabilities allow attackers to store malicious JavaScript in your database, which will be executed when other users view your site. So we've seen that. You might want to check, let's see, in it's probably cross-site scripting, so part 2, part 3, part 2 and part 3. Alright, there is another way attackers can use XSS to inject malicious JavaScript called reflected XSS attack. If your website takes any part of the HTTP request from a user and displays it back to them, so the HTTP request is made of headers and the body. So wherever in that HTTP request your website takes input from the user and displays it back to them, you could be enabling another vector by which malicious actors could inject JavaScript. So this guy is a hacker who has noticed that your website, that your site's search function passes search terms in the URL. Alright, so I believe that it actually passes stuff here. Let's move on. He knows the search terms in the URL will get displayed back on the search result page, and he wonders if they are escaped properly. To test this, he crafts a URL with snippet of JavaScript in the search parameter, for example, this one. In this situation, it actually looks at window.location, which is actually, he's trying to control the URL. So he's trying to set the URL to this one and actually take the cookie. So he's basically sending himself, noting that this is the website he controls, or this is a URL he controls. He's actually sending himself your cookie via the window.location call in JavaScript. So to test this, he crafts a URL with a snippet of JavaScript in the search parameter. Sure enough, when he drops in the URL in his browser, the injected JavaScript is executed and the browser redirects to his malicious site. Now he has to trick someone into navigating to the URL, someone like the victim here. Mal sends Vic an email with a very tempting link pointing at the crafted URL. So it often is, and I actually get a lot of spam emails in some of my email boxes, and some of them are quite close to being trustworthy. And I cannot blame anyone who's not into the cybersecurity field who actually falls for these scams. Alright, now, Vic clicks on the link. The page renders the search parameter in the HTML without escaping it properly, which creates a new script tag on the page. So in this situation, window.location over here is set to his to a domain that he controls. So he's actually injecting search results. So this is basically what's his input in the search term. So his input is script all the way up to here. The script is executed immediately when the page loads. And Vic gets redirected to Mel's malicious website. He doesn't even have to get redirected. They could actually inject an iframe in this situation and actually make it hidden so everything happens in the background and the victim isn't even aware of that. So it is very, very good practice not to click on untrustworthy links. So Mal can now check his server logs. Okay, let's go back. Mal can now check his server log and hijack Vic's session since the malicious redirect passes his session ID in the URL. So this is the server log. This is what's been passed. So as we can see previously, where was it? Over here. So window.location, in this situation, it's actually setting the window.location. It's kind of a dummy or sort of like bad, maybe stupid way of going about it. Window.location, he's actually setting the location to, he's setting the URL here to his control domain and the cookie of that URL to document.cookie. Like I said, there are clever ways to do this when you're testing for XSS, or hackers actually implement much more, so not hackers, but malicious attackers actually, or bad actors, threat actors actually use much more stealthy ways to steal victims' credentials. And as you can see in this situation, he gets the cookie. When he looks into his server log, he sees that his controlled domain has been accessed and the cookie has been set to victims' cookies. Now he could use the cookie to actually craft requests in the name of those victims. All your sessions are belong to us. That's a word in cybersecurity. Alright, now this has been the attack. Now in the next video we're actually going to look at protecting your users against reflected XSS. So this was, the first video was attacks. Now the next video is going to be the defenses against reflected XSS.